In this video, we're going to talk about arithmetic sequences as linear functions. Go ahead and pause and copy down all the information, and we'll go ahead and get started. Okay, so basically all you need in this portion is the highlighted parts. So an arithmetic sequence, so we're just going to define that as a numerical pattern. And it increases and decreases at a constant rate. So once you write that down, also write down both of the examples, okay? So notice that the example on the left is 3, 5, 7, 9, 11, and the rate of increase is adding 2 every time, okay? And then the example on the right, notice that you are decreasing by 4 or subtracting 4 every single time. So that is the difference between a geometric and an arithmetic sequence, is that the difference is constant. Okay? Now, let's start with the first example. We're going to take a pattern and we're going to decide if it's an arithmetic sequence or not. So basically, all you have to do is go through and find the pattern. And so if we go from 15 to negative 13, that is plus 2. And if we go from negative 13 to 11, that is plus 2. And just to double check it, we're going to go from negative 11 to negative 9, and that is also plus 2. So your answer for this one would be yes, it's an arithmetic sequence because the increase is constant. That's your explanation. Okay? That's all you have to write. So let's move on to the next one. Go ahead and pause the video. Don't freak out at the fractions. They all have a common denominator, so just subtract them, okay? So pause the video and figure this one out. So hopefully you went from 7 to 5, so that is a decrease of negative 2 over 8. And then from 5 to 1, that is a decrease of 4 over 8. And then from 1 to negative 5, that is a decrease of 6 over 8. So on that one, your answer would be a big old fat no, because the decrease is not constant. Now, what I mean by constant, and it has to be the same, okay? So if it was all a decrease of 2 over 8, 2 over 8, 2 over 8, then that would be fine. But because that top number is different, then it's not, and you just say no, it's not constant, and move on. Okay? So let's do this one. Go ahead and pause the video and try this one on your own. So the difference here is a plus 2. And then on the next one, notice that the difference is a plus 4. And then when you go from 8 to 10, that is back to a plus 2. And then 10 to 12 is also a plus 2. So even though you have 3 out of the 4 increases by 2's, that is still not going to be an arithmetic sequence because the increase is not constant. Okay, that plus 4 in there kind of ruined everything. Not constant. Okay, that's it. Simple enough, right? Okay, let's move to the next part where we have to find the next 3 terms in a sequence. Now, I've only got one example of this because seriously, you guys have been doing this forever and ever and ever. Okay, so to find the next 3 terms, of course, first you have to find your pattern. So in this instance, we go from negative 8 to negative 11, that is minus 3. And then negative 11 to negative 14 is minus 3. Negative 17, that's again minus 3, okay? So in order to find the next 3 terms of this sequence, you just continue the pattern on. So 17 minus 3 is negative 20. And then you subtract 3 again, and that's negative 23. and then you subtract 3 again, and then that's negative 26. So those are the next 3 terms in the sequence, okay? Fairly straightforward, simple, moving on. Okay, now here we go. We have to write the equation or the rule, okay, to find the nth term of the sequence. That means that here you're given the first 4 numbers of a pattern, and what if I want to find the 98th term in this pattern? There's a very easy, quick way to figure out the rule, okay? So what you want to do first, I'm going to write down the steps, okay? So what you want to do first is you want to make a table out of it. Now, whenever you have a number sequence, that is always the output of an input-output table, okay? And then, so second, we are going to find the pattern. And then third, we are going to find what I call the 0th term, and that'll make more sense in just a second, okay? And then that 0 term is going to be your B. And then last, we are going to put everything together in this form, mx plus b. Okay, so one thing I forgot is back up here at the pattern, that's your m. Okay, yes, we use m for slope, so that's your slope. All right, so write down those 4 steps and then we'll move on. Okay, here we go. We're going to make a table. So we have 1, 10, 19, and 28. So make those into a table of values. Okay, so now the 1 is the first term in the sequence, so that gets a 1. The 10 is the second term in the sequence, so that's a 2, and then so on and so forth, 3 and 4. Okay, so now what you want to do is you want to go through and you want to find your pattern. So to get from 1 to 10, okay, that's a plus 9, and then 10 to 19 is a plus 9, and then 19 to 28 is a plus 9. Okay, so now that we have our slope, we want to go through and we want to find our 0th term. Well, all you're going to do is go 1 backwards. So in order to go from 1 to the 0th term, you just work backwards and subtract 9, so that's going to give you a 0th term of negative 8. Okay, so now the B is your negative 8 and the pattern is 9, that's your M, and you're just going to put it in the form of mx plus b. So that's going to be 9x minus 8. Okay, so you can always check your rule by plugging in the values in your table. So remember, in an input-output table, the x's are on top and the y's are on the bottom. So if you take your sequence number, so like let's do the 3rd term, just to do it. So if you plug in 3 for x, you get 9 times 3 is 27. Okay, and 27 minus 8 gives you the 19 that is matched with the 3. All right? All right, so let's do one more. I want you to do this one on your own. Do not sit and copy all of that down. Just copy the sequence of numbers, the 2, 7, 12, 17, and 22, and then I want you to go through and find the equation or the rule for the nth term of the sequence. Okay, go ahead and pause. Okay, so hopefully when you went through and you found your pattern, you said that each and every time you are increasing by 5. Okay, that's your M. And then you're going to go through and you are going to find your 0th term by subtracting 5, and so you get a 0th term of negative 3, and that is your B. And then last but not least, when you go through to write your rule, you have mx plus or minus b. So you have 5x minus 3. And then if you want to go through and check, let's check it and see. So let's try the 4. If we have 5 times 4 minus 3, we have 20 minus 3, and that does indeed give us the 17 we need. Okay? So that's working with arithmetic sequences. So here is a copy of what my notes look like, just in case you have any questions, okay? So make sure you bring your questions to class, and I will see you tomorrow.